Hello friends, this video sets part 14 is brought to you by examfear.com. Before watching this video, you should have watched sets part 1 to part 13. Now we'll discuss number of elements in a set. Number of elements in a set is nothing but number of unique elements in a set. And the formula here is number of elements in A union B, that is the whole range from here to here, is equal to number of element in A plus number of element in B minus number of element, that is A intersection B. Now let's visualize how this formula came. Number of element in A is the one which is in this line, a tilted lines, and the number of element which is in B is, let's suppose, in horizontal line. So when I say number of element in A plus number of element B, I am including this area plus this area. As you have noticed that this area is calculated twice. Once when I was adding number of elements in A, and second times when I was adding number of elements in B. That's why we have to subtract this area. And this area is nothing but number in A intersection B. And that's why this formula came. Number of element in A union B is equal to number of element in A, this area, plus number of element in B, this area, minus the area which you have calculated twice. So what you get is the whole set. This is number of element in A union B. This whole thing is the answer. I have got the point. Number of element in A union B is number of element in A plus number of element in B minus number of element in A intersection B. It's a very important formula. Please make a note of this. Similarly, for this problem, when we say number of element in A union B union C, this is equal to number of element in A plus number of element in B plus number of element in C minus number of element in A intersection B minus number of element in B intersection C and minus number of element in A intersection C. And then we add the number of element in A intersection B intersection C. Let's solve this. So all the elements in A, let me write with the vertical line. Let me draw with the vertical line. So these are number of elements in A. And number of element in B, let me draw with the horizontal line. These are number of elements in B. And number of element in C, because this we have added, now this we have added. And the third thing we'll add is number of element in C. So let's add number of element in C. We'll create a star mark thing, or we'll say star is better. So we'll create a star thing. Everything that is in star is number of element in C. So this is what we have done, number of element in A plus number of element in B, number of element in C. So what we observe here is this area, you see, is counted by this twice. This area is also counted. This area is counted thrice actually. So I'll say this area is counted twice. I'll write 2 here. This area is counted twice, one with star, one with a horizontal line. This area is also counted twice, one with the vertical line, one with the star. And this area is counted thrice. That is a scenario. So now what we are doing is, we are saying minus A intersection B. So when you say in A intersection B, it covers this area. So this is gone. So when you say this, it covers this area. When you say this, it covers this area. But when you subtract these three, suppose this, this and this, what happens is we observe that this is gone. It was counted thrice only, and you have subtracted 3 times. So this area is no longer counted. So we have to add this once again. Let me repeat this. If you see this, I'll write 1 1 here because these areas are counted only once. So we need to count all this area once. So since this area is counted once, this area is counted once, this area is counted once, we don't have any issue. These areas is counted twice, so we have to subtract this. And this area is also counted thrice, so we have to subtract 2 of this. So when we subtract NA intersection B, now let's suppose, so this area is subtracted. So this is 1 now, 1 is gone, and this becomes 2 because one part is gone. Now when I subtract B intersection C is this area. This also becomes 1 because 1 is subtracted, and this also becomes 1 because 1 is also subtracted from here, because B intersection C is this area. Now when I say A intersection C, this area also from 2 it becomes 1, and this area from 1 it becomes 0. Now when you see that what we have done till now is we have added all this once, but this is never counted. So we'll add this once, and that's we got the formula. We have to count all the elements only one. We found that this three boxes were counted twice and this was counted thrice. So we subtracted these boxes. When you subtract this box, both are subtracted. When you subtract this box, both this end is subtracted. When you subtract this box, both this end is subtracted. So when we have subtracted these three, we have seen that this was counted thrice and this became 0 because this was subtracted 3 times, 1 each in all these 3 cases. So we have to again add this. So we have added this saying plus and A intersection B intersection C, because this area is nothing but A intersection, this area is A intersection B intersection. Now we'll do an element count problem. First let's understand what the question is saying. A union B is 50, number of A is 28, number of B is 32. So let me first write here, number of A union B is 50, number of element in A is 28, and number of element in B is 30. Now we can solve this question directly using formula or using Venn diagram. First let's solve directly using formula. Formula says n of A union B, and also we have to find any A intersection B, is equal to n of A plus n of B minus n of A intersection B. So it says 50 is equal to 28 plus 32 minus n of A intersection B. You solve this, you get n of A intersection B is equal to 10. Now let's solve this question using Venn diagram. So this is set A, this is set B. So they are common element A intersection B, we have to find. Let me assume it is X. It says A has 28 element. So this whole thing is 28. So this guy will be 28 minus X, because X already I have included here. So if you add this, it becomes 28 minus X plus X. So this guy is 32 minus X, and you add 32 minus X plus X, it's equal to 32. Now we have to find X. Already we have been told that when you say A union B, that becomes 50. So when you add this 28 minus X plus 32 minus X, this guy is equal to 50, or 60, this guy is gone, minus X is equal to 50, or X is equal to 10. Answer. So we have seen that we have found the solution to this question both using the formula and using Venn diagram. But I recommend using Venn diagram because you get a clear picture. Let's take one more element count problem. So there is a school where there are 20 teachers who teach physics or mathematics, 12 teach mathematics, 4 teach physics and mathematics. How many teach physics? So let me write this mathematical question in mathematical form. So it says there are 20 teachers who teach mathematics or physics. So mathematics or physics is equal to 12 teach mathematics, number of mathematics is 12, 4 teach both physics and mathematics, M intersection is 4. Now we have to find n of. Similarly, we can either use the formula is simple, the formula is n of M union P is equal to n of M plus n of P minus n of M intersection P. We get 20 is equal to 12 plus n of P minus 4, or we get 20 minus 12 plus 4 is equal to n of P, or n of P is equal to 12. If you want to solve the same question in Venn diagram, what we do is we create this Venn diagram. We'll create 2 boxes, and since we know there's an intersection between N and P, they are elements, so we'll create an intersecting box and says this is M, this is P. M intersection P is 4, we'll put a 4 here. M is 12, 8 plus 4 is 12, so we'll put 8 here. M, and this is, let's suppose X, we don't know the value. So we'll say 8 plus 4 plus X, we'll add all this thing. What you get is N of M union 2. So this is equal to 20, or X is equal to 20 minus 12 is equal to 8. Now since X is 8 here, the number of element in P is nothing but 4 plus 8. Everything that comes in this box. So this is equal to 12. Understand?
Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors,